This topic is called the union and intersection of intervals. So what we want to be able to do is take these two given intervals, in this case A and B, and find their intersection and find their union. So generally a very good idea to get started is to draw a number line and to carefully mark off the two numbers that, or whatever numbers that you're dealing with. In many cases there could be more than two. In this case, we just have 4 and 5. Important that we list them in the correct order. In other words, 4 is to the left of 5 on the number line. And then carefully draw out or represent graphically our two sets. So set A is the set of numbers that are less than 4. We represent that graphically with an open circle and shade everywhere to the left of that open circle. And set B, so that's A. Set B is a set of all numbers that are greater than or equal to 5. We represent that with a solid circle and graph everywhere to the right of that solid circle. And I'll talk here in a minute about why I for doing this, tend to draw above the number line as opposed to on the number line. All I'm trying to do is give a sense of what is represented by set A, what is represented by set B, and to do that on the same number line without making it too cluttered. So A is to the left of 4, B is to the right of 5 and including 5. And now we're ready to analyze what's the intersection, what's the union. So that much we're going to do regardless of the problem. Then we're going to look at the problem individually and figure out what the intersection, what the union is going to be. So A union B, that's the union. We think of that as the set of all numbers that are either in set A or set B. So in terms of our picture, I think about this as paint. Picture the number line and then just say to yourself, how much of the number line got painted at all? Whether it's blue paint, green paint, doesn't make any difference. How much of the number line got painted? Well, in this case, everything to the left of 4 got painted, and everything from 5 and to the right got painted. So the only way to represent that, and it says using interval notation, is to turn around and say, well, negative infinity up to 4, that represents everything to the left of 4, union from 5 on out to positive infinity. That represents every number to the right of and including 5. Now, this is kind of an odd one to get started with, but it's the one we got. So another analogy I mentioned to students here is think of this as somewhat similar to adding like terms that aren't like. So in other words, if I said, hey, what's 2x plus 5? Well, the best you can tell me is that's 2x plus 5. So in this case, the union of these two sets is the union of these two sets. That's kind of an oddball one to start with, but that's, as I said, that's kind of the way it works out. The intersection, on the other hand, is interesting and a good thing to talk about here as well. Intersection of these two sets is, and again, you would ask yourself the same question regardless of the setup. So you're going to draw the number line, you're going to shade sets A, sets B, and then you're going to analyze. So, and I'll do another example or two here in just a moment. So in this case, the intersection is the overlapping portion. Intersection is the set of numbers that are in both A and B. Well, are there any numbers that are in A, which is to the left of 4, and in B, which is to the right of or including 5? And the answer to that is no. So that last sentence they gave us in the instructions becomes important here, because the set represented by the intersection of A and B is empty. So we give the empty set as our solution. Now I'm going to turn this around just a little bit and make up a slightly different problem. So I'll scoot this down. I'm going to say, let's change this just a little bit. Let's pretend that it was given that set A was the set of all real numbers greater than 4. And set B was the set of all real numbers less than or equal to 5. So again, I'm making up a different problem here, just for comparison. And what we would do to get started is exactly the same thing we did before. We'd draw a number line. We'd say here's 4, here's 5. Set A is everything to the right of 4, not including 4, so open circle, shade everywhere to the right. Set B, oops, I wanted to label that, so that's my set A. Set B is everything to the left of and including 5, so that's solid circle. I'm going to draw this intentionally a little bit below that blue line. Important to say that it goes everywhere to the left of 5. So now look carefully. The union, and again think about the paint analogy, is how much of the number line got any paint at all? Well, what got paint? Looks like everything did. To the left of 4 has some paint, in between 4 and 5 has some paint, to the right of 5 has some paint. So the entire number line got painted. So we represent that in interval notation by negative infinity to infinity. A intersect B, so the intersection of these two sets is thought of, or you can think of, how much of the number line got 2 coats of paint. 2 coats meaning the overlap, the set of numbers that are in A and B. Well, if you look carefully, only the set of numbers that are in between 4 and 5 got 2 coats. And if we analyze this more carefully, right at the number 4, if you look right at the number 4, it did not get 2 coats of paint. Right at 4 only got coated by B, only got green. It just barely didn't get any blue paint. So we're going to have to say between 4 and 5, we cannot include 4 in the overlapping portion in the intersection, but we can include 5. If you look at 5, it in fact got 2 coats of paint. So the intersection or overlapping portion of these sets is between 4 and 5, not including 4, but including 5. I'll do one more example, and then we'll call this quits. Change it just slightly more and say, well, pretend set A is all real numbers that are greater than 4. Oops. All real numbers that are greater than 4. And set B, let that be all real numbers that are greater than or equal to 5. So let's start down the same road. Let's draw a number line. Let's mark 4, mark 5, and say, and look carefully at what's going on. Set A is greater than 4. All real numbers greater than 4. Set B is all real numbers greater than or equal to 5. So now we have to look carefully at our questions again. The union of A and B is the set of all numbers that are in both A and B. And to stick with our paint analogy, you just ask yourself how much of the number line got paint. 1 coat, 2 coats, doesn't matter, just how much got paint. And the answer to that question, if you look, is anything to the right of 4 got some paint on it. For intersection, on the other hand, you ask yourself how much of the number line got 2 coats of paint. Well, if you analyze that number line carefully, the only portion that got 2 coats is actually over on the right-hand side, to the right of 5. And in fact, it includes 5. So we're going to write bracket 5 to infinity. So hope that helps. Again, that's our topic on finding intersections and unions of intervals.